High salinity levels in soil health are pressing concerns in modern agriculture. An estimated 20 to 33% of irrigated and cultivated land globally are affected, and researchers estimate by the year 2050 that at least 50% of the global agriculture fields will be affected. The main issues with high salinity within agriculture include the impacts on plant health and crop production. Salt stress affects the metabolic process within plant cells, causing an inhibition leading to damage of cellular structures. In addition, abrasic acid levels increase, causing stomatal closure, reducing transpiration. The reasoning behind my choice to investigate Bacillus is due to its classification as a plant growth promoting rhizobacteria. Plant growth promoting rhizobacteria, or PGPR, is a class of bacteria found naturally within the soil. PGPR improves nutrient uptake and enhances plant growth and tolerance to various stresses, including salt stress. The three specific mechanisms that contribute to the promotion of plant growth under salt stress include establishing ion and osmotic homeostasis, preventing damage to the cells of the plants, and then resuming the growth of the plants under the high salinity condition. The four species of Bacillus I investigated were Bacillus subtilis, Bacillus megaterium, Bacillus cereus, and Bacillus thuringiensis due to their already known uses in agriculture and science, as well as their known abilities to decrease plant stress in high salinity environments. Within my research, I investigated these species on Arabidopsis thaliana under two separate salinity conditions. The conditions were ranges of electrical conductivity, or EC, which is how conductive the soil is. So a higher EC means a higher salinity. The ranges I used were a 4 to 8 DSPM, or decisiemens per meters, and then an 8 to 16 decisiemens per meters, or ds/ams. Through my research, I determined that Bacillus cereus exhibited the highest germination, with all samples germinating at both EC 4 to 8s and at 8 to 16s. Bacillus thuringiensis showed full germination at EC 4 to 8, but 4 of 5 samples germinated at EC 8 to 16. Both species then outperformed Bacillus megaterium and Bacillus subtilis, especially at higher salinity. Bacillus megaterium showed moderate germination at the EC 4 to 8s, with 4 out of 5 germinating, but only 2 samples germinated at 8 to 16, with B. subtilis performing the worst with minimal germination in both salinity ranges, with only 2 sprouting in the 4 to 8 range and only 1 sprouting in the 8 to 16 range. Within the EC of 4 to 8 DSPMs, B. thuringiensis achieved the longest average lifespan of 36 days, followed by B. cereus with an average of 27.8 days, B. megaterium with 25.6 days, and B. subtilis with 16.6 days, which is then including the non-germinated samples. However, excluding non-germinated samples, B. subtilis displayed the highest lifespan of 41.5 days on average, outperforming B. thuringiensis of 36 days, B. megaterium with 32 days, and B. cereus of 27.8 days. However, B. subtilis result was based on fewer samples, while B. thuringiensis showed consistent and maximum and minimum lifespans with larger variability. Including non-germinated samples, B. thuringiensis had the longest overall average lifespan. In the EC rating of 8 to 16 DSPMs, B. cereus demonstrated the highest average lifespan, including the non-germinated samples, closely followed by B. thuringiensis. When excluding the non-germinated samples, B. thuringiensis showed the longest lifespan at 30.25 days, surpassing B. cereus's 25.2 days. B. megaterium and B. subtilis performed comparably but had limited data. B. cereus exhibited the longest data variability, while B. thuringiensis showed more consistency. Due to sample sizes for B. megaterium and B. subtilis, determining the best performance species remains uncertain. However, the current data suggests B. thuringiensis as the most effective species in supporting plant longevity under high salinity. Now, at the EC of 4 to 8 DSPMs, Bacillus thuringiensis exhibited the largest average growth of 1.8 centimeters, surpassing other species, with B. cereus at 0.94 cms, B. megaterium at 0.41 centimeters, and Bacillus subtilis at 0.25 centimeters. Notably, B. thuringiensis also achieved the tallest plant and was the only species to produce a mature plant with buds and flowers. Most other treated plants remained short and failed to reach maturity, with Bacillus cereus, Bacillus megaterium, and Bacillus subtilis samples rarely exceeding over 1 centimeter. Overall, Bacillus thuringiensis had the greatest impact on growth and maturity, while Bacillus subtilis showed the least. At the salinity levels of 8 to 16 DSPMs per m, Bacillus thuringiensis showed the greatest effect with a maximum average height of 0.53 centimeters, followed by Bacillus cereus at 0.36 centimeters, Bacillus subtilis at 0.2 centimeters, and Bacillus megaterium at 0.15 centimeters. Bacillus thuringiensis also produced the tallest plant at 1 centimeter, consistent with its performance at 4 to 8 decisems per meter. However, no plants reached maturity before death at this salinity. B. megaterium had the poorest performance, while Bacillus thuringiensis remained the most effective species in promoting growth at high salinity levels. Overall, Bacillus thuringiensis outperformed the other species in germination, plant lifespan, and maximum plant height in high salinity environments.